Hi, welcome to this lesson on Euclidean geometry, the proportionality theorem. Let's have a look at question 1. In triangle MNP, we're given that angle M is 90 degrees and that HJ is parallel to MP. We're also given a proportion HN, so this side here, to MH, this side here, is 3:1. We're also given that HM is X units and JP is Y units. So firstly, they want us to calculate the ratio JP, so this ratio here, to this ratio here, NP, which is this large ratio. Okay, so let's see how we would do this. Well, first of all, notice that because these two lines HJ and MP are parallel, we should have a proportion going on here by the proportionality theorem. So essentially, if I look at JP over NP, for example, then that means that MH over the total length MN is in the same proportion by the proportionality theorem. So that is equal to MH all over MN. And the reason for that is prop theorem. Okay? Because we know that HJ is parallel to MP. Alright, but we know the length of MH is X, so we can just need to work out the length of MN. But we were given this information here. HN over MH is equal to 3/1, which is 3. Okay, so that means the length of HN, if I multiply both sides by MH, is 3 times MH, but MH is given as X, so that's 3X. So therefore, this total length of HN, the small one here, is 3X. Okay, so therefore, this total distance of MN is 3x plus 4x. 3x plus x is 4x. Okay, so therefore, JP over NP, that's what we're looking for, is MH, which we know is X. Okay, HMMH, same one, over MN, and MN we worked out as 4x. So x goes into x once, so that's 1x, so you're left with a quarter. So therefore the ratio of JP to NP is equal to 1:4. Okay, so that is the ratio of JP to NP. Alright, next we want to calculate the value of the ratio area of triangle HNJ to area of triangle MNP. So let's go put some information down. So we worked out this is 3x. So by the proportionality theorem, this should be 3y, because we should have this two ratios here, x over 3x should be the same as y over 3y, because they're both simplified down to 1/3. Okay? And moreover, I want to note that in triangle NHJ, angle H equals 90 degrees. This is 90 degrees. And how do I know that? Well, I know that HJ is parallel to MP, so therefore corresponding angles are equal. So the corresponding angle is this one here. Okay, so now I have two right angle triangles. So in triangle NJH, the area of triangle, or HNJ, that's how we're calling it here, that's equal to half times the base 3x times this perpendicular height HJ. Alright? And then the area, so let's do it in a different color so we can see it here. The area of triangle MNP, so the larger triangle MNP, that's going to be half times the base, which in this case is MNP, that's 3x plus x, so that's 4x, okay, times the perpendicular height, which in this case is MP. Alright, so we need to work out what those perpendicular heights are, and then we can consider the ratios between them. So in triangle MNP, we have the following. We have this side 4x, right? So 4x squared plus this side here, MP, which is what we're looking for, mp squared equals the hypotenuse squared, which is 3y plus y, which is 4y, all squared. So therefore, mp squared equals 4y squared minus 4x squared. Okay, and if I square those terms in the brackets, I get 16y squared minus 16x squared. All right, so that's mp squared. So therefore, mp is just the square root of that expression. Okay, and then in triangle NHJ or HNJ, we have this side here, HN, so 3x all squared, plus the side HJ that we're looking for, HJ squared, equals NJ squared, which is 3y all squared. So again, HJ squared equals, so 3y squared is 9y squared, and then 3x all squared is 9x squared, and we're subtracting that. So therefore, HJ is the square root of 9y squared minus 9x squared. Okay, so now that we've got those values, we can substitute it in. It's going to be a half times 3x times the square root. Okay, so what I'm going to do is I'm going to simplify these. So I can take out a common factor of 9, and I'm left with y squared minus x squared. So taking the square root of that is the square root of 9 times the square root of y squared minus x squared. So I'm using my algebraic toolkit here in terms of surds. The square root of 9 is 3, and you have y squared minus x squared, all square rooted. And I can do a similar thing here. So I can take out 16 as a common factor, and I'm left with y squared minus x squared. And then the square root of 16 is 4, and then we have times square root of y squared minus x squared. Okay, so this is equal to a half times 4x times 4 times the square root of y squared minus x squared. And then over here, I have a half times 3x times 3 times the square root of y squared minus x squared. So doing these algebraic manipulations is necessary so that when we divide out, there are terms that are equal to each other and we can divide them out. So therefore, the area of triangle HNJ divided by the area of triangle MNP. So that's going to be 1/2, 3 times 3 is 9, times x times the square root of y squared minus x squared. That's the first one. Divided by a half times 4 times 4 is 16, times x times the square root of y squared minus x squared. So you see x's will divide into each other, these square root terms will divide into each other, the halves will divide into each other, and we're left with 9/16. Okay, and that is the simplified ratio of those two areas. Okay, so to summarize, we needed to use, first of all, construct two right-angled triangles. Once we had that, using parallel lines and corresponding angles, we're then able to use the area, right, or right-angled triangle being half the base times the perpendicular height. But to find these perpendicular heights, we needed the theorem of Pythagoras. And we simplified those expressions for the heights, substituted them back in to the areas, and then divided the areas out. All right, so that is how we would do this type of question. I'll see you in the next one.